Alright, hi everyone. Welcome to the fifth lesson for topic 4.2 Kinematics of Motions in Straight Line. So today we'll be in the second last lesson, so which means by next Monday, then it will be the last lesson, then we'll kind of finish this topic, then we can move on. Alright, so let's look at today's learning outcome. So today we are going to learn how to use differentiation with respect to time to solve simple problems that involve displacement, velocity, and acceleration. Okay, so the differentiation skills that you need are only the techniques from P1, so which means that you doesn't need the knowledge for P3 for the differentiation here. Okay, so basically the things that we are going to look at is for the previous lesson, right? The case that we are looking at is like the Subat formula, so which is based on the situation where there is constant acceleration. So this one is actually the situation of variable acceleration. So which means that in a lot of cases, we do not have exactly constant acceleration. So that's why we will need to use this technique to actually help us to solve the problems that the acceleration changes according to the time. All right. So before we look at the today's lesson, we'll be doing a very quick recap on the differentiation knowledge that we have learned previously. All right. So let's start the lesson. Alright, so let's start off with the basic differentiation techniques. So you should be quite familiar with it. So we are just going to do a very quick one so to have a recap on it. Okay, so if we have an equation that y equals to x to the power of n, the dy dx will be equal to power bring to the front, right? Then after that, power minus 1. Okay, if let's say you have a you have a constant in front, so it's still going to be the same. So n will multiply with a, then x, so same thing, power minus 1. So if let's say you have different terms that connected by addition or subtraction, so it's just going to be the exactly same thing like how you differentiate a single term, then the plus or minus sign will just follow the plus and minus sign that you have. All right, so m minus 1. Okay, so this is for composite function. So if you have things like 3, then x minus 1 to the power of 3. Yeah, so this is the composite function. So what you need to do is same thing, bring the power in front, then you can just copy the exactly same thing and then power minus 1. Okay, and don't forget because it's a composite function, so that's why you need to differentiate whatever that is inside your bracket. Okay, so which means for this one, then you'll be able to get your answer inside. Okay, for example, if let's say I put 2 here, okay, so which means after I differentiate it, then I'll be able to get like 9 and then 2x minus 1 to the power of 2, and don't forget differentiate inside, so I have 2. So my final answer will be 18 and then 2x minus 1 to the power of 2. Okay, so as simple as that. Okay, then in P1, when we learn about differentiation, we also know that dy dx basically mean the rate of change of y with respect to x, right? So why we are using dy dx is because of, for example, if let's say I have this curve, okay, so you will realize that you can draw all different tangent on this curve, and all this tangent will give you different gradient, and it's quite impossible for us to actually calculate it one by one. So that's why I'm not going to explain the theory, yeah, because we did it before, right? And it's not so important in here. So basically you just need to understand dy dx tells you that what is the rate of change of y when x changes. All right, so that's why the rate of change of y and x is basically tell us about the gradient, right? So if let's say we have a function that y equals to f of x, so dy dx is basically the gradient function of y. Okay, so which means if you know what is the position of x, then you can just substitute your x inside the gradient function, then you will be able to get the gradient at the specific point for the tangent. Okay, so in that chapter, we also learned about the increasing and decreasing function. So increasing function would look something like this, right? So this is like a increasing graph. Then after that, this is like a decreasing one. So what you can realize here is if let's say I try to draw different tangent on this curve, and you will realize that for all this tangent, when x increase, actually the y increase. So that's why the rate of change for this curve will always be a positive number because the gradient is positive, right? So that's why if we have the tangent is always greater than 0 for that interval, which means that the function is going to be an increasing function. So which means that won't be any decreasing throughout the interval that you have if your gradient is always positive. So it's the same thing when you look at this graph. So all the tangent that you try to draw here will be a negative number. So when x increases, you can definitely see that the y decreasing. So that's why all these tangent will have a negative gradient. So that's why the dy dx will be a negative one throughout the interval. All right, then the last part, we also learn about the stationary point. So which means if let's say it's a minimum point, so it's going to look like this, right? So you can imagine at this point, this graph is having a negative gradient. So it's negative. All right, so when you reaches here, right, you will have a tangent that look like this. So the gradient for a horizontal line, it will be 0, correct? Then after that, when you move to here, then it will be positive. So you can see that when x increases, right, your dy dx here, actually what happened? When x increasing, so when you move along to the right hand side, you can see that the dy dx is actually increasing because from negative to 0 to positive. So that's why if you have a minimum point, then the dy dx should be equals to 0. But then don't forget, because of maximum point, you also have dy dx equals to 0. So that's why we need this. So when x increases, dy dx increases, so which means that the rate of change of dy dx increases as x increases. So that's why we have the second derivative, which is d square y over dx squared is greater than 0. Okay, because it's increasing. Then for this, it's going to be the same. So this is positive and then 0, then go back to negative. So you can see when x increases, as you move to your right hand side, your dy dx actually decreasing. Okay, so at maximum point, the dy dx will be 0 as well, but then your second derivative, meaning the rate of change of dy dx with respect to x, is going to be decreasing. So that's why you will have a negative d square y dx square. All right, so that's a part. I hope that you are still remembering all of this. So now we are going to look at the part when we talk about the kinematics in variable acceleration. Alright, so in this lesson, we're going to talk about to use differentiation to describe the straight line motion. So for integration, we'll bring it to next Monday. Alright, so in previous lesson, the straight line motion that we have is either the velocity or the acceleration is a constant. So which means if you remember for all the cases that we are using Subat formula, right? If let's say it's a horizontal motion, so normally the question will let you know that it has a constant acceleration. So if let's say it's a vertical motion, right, then you are definitely going to have a constant acceleration because it's just going to be g equals to 10. You get what I mean? Yeah. So that's why you must remember that in the case where the acceleration is not constant, then you cannot use Subat, but only to use differentiation and integration. All right. So like what we mentioned just now, so often in real life, right, our acceleration wouldn't be constant. So for example, if let's say you try to you are driving a car, so you come out from your house, then after that you go on a highway. So you can imagine the acceleration you when you first drive out from your home will definitely is going to be lesser than the acceleration when you first reaches the highway. You get, yeah, if you can get what I mean, because the rate of change of your velocity is definitely going to be different. So for example, at your home, it's just going to be like start the engine, then maybe you drive at 30. After that, when you go to on a highway, then maybe it's from a 30 to 100. So that's what I mean. Okay, so that's why in real life, the acceleration is of object is always changing with time. So if let's say we try to look at this displacement time graph, right? The previous idea that we have is if let's say it's a straight line, then for this case, it's just going to be when the t increasing, then what happened is the displacement increasing, right? And what you can realize here, because it's a constant, so that's why all the gradient that I have over here is basically the same. So it actually tell me that I have my v is a constant one, right? Okay, but in real life, what happened is that perhaps I'll have cases like this. So if let's say it's like a curve, okay, So it's the same thing. You can see that when t increasing, your s also increasing as well. And when you try to look at this, right, then definitely you can see that for, if let's say I try to draw the tangent over here and I try to draw the tangent here, it's still going to be positive, right? The velocity is always positive. So meaning that it's still moving forward with a certain speed. But then in this case, you will realize that when I try to compare the gradient here and I try to compare the gradient here, it's definitely going to give me different answer because steepness here, the steepness here is going to be larger than here. You get what I mean? Yeah. So that's why when you try to look at this, right, actually you can see that the ds dt, so meaning the gradient here, eventually actually increasing. So that's why we have our v is increasing as well. So if our v is increasing, right, actually what happened here, you have a positive acceleration. So that's the idea. So similarly, if I have a curve that looks like this, so what happened? So you can realize here that for when t increasing, actually my s also increasing, right? But what happened is the rate of change of x actually decreasing. So when I try to compare a tangent here and I try to compare the tangent here, so definitely my gradient here is going to be smaller than the gradient here. So that's why when time increases, my ds dt actually decreases. My gradient is decreasing. Okay, so which means that my velocity is actually decreasing. So it's actually very easy to see that. Like for example, if here is 0 to 5, right? So you can see from 0 to 5, the change in displacement is like this much. But if let's say I try to see 15 to 10 to 15, then the change in the displacement is only this much. So that's why it's because of the velocity is like slowing down. So that's why your displacement is getting smaller when time move on. So that's why in this case, actually what happened, you are actually having a deceleration. Okay, because your speed eventually going down. All right, so I hope that you can get this idea. So all right, so in pure max 1 we actually use differentiation to help us to find the gradient for the tangent, right? So we are going to do the same thing for displacement time graph and velocity time graph if let's say it is a curve. Okay, so the idea is basically the same. So for a normal curve, then for each of the tangent, then we use dy dx. So in this case, because of it's going to be a displacement time graph, and we know that the velocity is basically the gradient for the displacement time graph. So in another words, velocity is the rate of change of displacement. So that's why if let's say we want to find the velocity, then we can always differentiate the function for displacement. So or in another words, it's rate of change of displacement. So that's why it's going to be ds with respect to time, so dt. Okay, so it's the same thing because here I'm going to have my time and s, right? So that's why the tangent that I find here is going to be dt ds lah, because of this it's like y and x here. So it's going to be the same thing for velocity time graph later. Okay, so when we have this, right, then the maximum displacement occurs when our ds dt is equal to 0. So if you can recall from the recap just now, so the maximum point or the minimum point happens when dy dx equals to 0. And we say that dy dx is equals to 0, right? It's actually the maximum y or maximum x. Sorry, is maximum y or minimum y. So like for example here and here, it's not about the x, right? It's about the y. So like maximum is also the y is maximum. Here also for minimum is also the y is minimum. So in this case, if we are finding the maximum displacement, then it will be ds dt equals to 0. Okay, so by having this also, you might have a question. If let's say for maximum point or minimum point, when we want to prove, right, we need to show that the second derivative is greater than 0 or smaller than 0. So for maximum displacement, do I need to do second derivative to show that it's maximum? So you can think about it. Yeah. So the answer is no, you doesn't need to do that. Okay, so the idea is like this. If you can remember, displacement involve positive direction and negative direction. Am I right? So if let's say it's a positive number, then it will be fine lah, because it's going to give you the maximum displacement. So the higher the number in positive, then you get the maximum. But don't forget, if let's say you get a negative number, for example, like negative 21. So is this a maximum displacement? Yeah, yes, right. Because like for example here, this is my 0. Okay, then after that I get my 15. So what do you think is my maximum displacement? Is it going to be 15 or negative 21? It's going to be negative 21, right? Although it's a smallest number, but in terms of displacement, meaning like the net change, actually negative 21 is eventually larger than 15. So that's why in this case, we do not need to check for the second derivative, because no matter is a maximum number or a minimum number, it's all considered maximum displacement. All right. So this means that in this case, if dy dx, if ds dt is 0, it means that v is equal to 0 and the particle is actually at rest. So it makes sense in the idea that if let's say this is my object, right, when it started to move until the maximum displacement, so if this is the maximum displacement, actually what is going on with the particle? The particle eventually, either it stopped, it doesn't move at all, or the other case is this is the point that the particle change direction. Am I right? And we know that if let's say there's a change of direction involved, then which means that the particle will actually stop for a while, then after that it only go back. So it's the same thing now. So that's why when the particle reaches the maximum displacement, it means that the ds dt is 0, and logically this is where the particle stop, and so that's why your velocity is 0. All right. Okay, so for this one, the acceleration is the rate of change of velocity. All right, so that's why it's going to be the derivative of velocity with respect to time now. So A is equal to dv dt. And by using to this idea, if let's say differentiate S, you can get V, right? Then now differentiate V, you get A. So which means that if let's say you are given for an equation for displacement, then you will need to differentiate 2 times so that you can get the dA. Okay, so the idea is easy. So from displacement to velocity, you differentiate 1 time. Okay, then after that, from velocity to acceleration, you need to differentiate 1 more time, right? So that's why if let's say you want to straight away do from S to A, then it will be differentiate 2 times lah. So basically that's the idea. So acceleration is the second derivative of displacement with respect to time. Okay, so similar to maximum displacement, the maximum velocity occurs when dv dt equals to 0. So we know that dv dt is a, so that's why at that time a is equal to 0. So which means the particle actually reaches a certain maximum velocity. So that's why there's no more change in velocity. So it also aligns with what we say dv dt equals to 0, so a is 0. So there's no acceleration, meaning that there's no change in velocity lah, because that's the maximum velocity achieved already. All right, so I hope that you can get this idea. I think it's quite easy, and you actually learn this during your IGCSE or SPM also. Okay, so now let's try to look at 4 example, then you can move on for your exercise. Alright, so example 1 is easy. It's basically just to introduce you to the idea. So yeah, if let's say you know how to do already, then feel free just do by your own, then after that check your answer. Okay, a ball moves in a straight line so that its displacement at time t is given that s is equal to 2t cubed minus 10t squared. So find the speed and the acceleration when t equals to 0. Okay, so I hope that it's very easy. So for speed, meaning that we are looking for the velocity first. So velocity is equal to the derivative of displacement with respect to time. All right, so we are going to differentiate this. So I'm going to get 6t squared minus 20t. All right, so by having this, then now I substitute when t equals to 2, what is my v? So 6, 2 square minus 20 times 2. Then I'll be able to get my answer, negative 16 meter per second. Okay, but don't forget this question is asking you for the speed. So a speed cannot have the direction. So that's why you're going to take the magnitude only. Okay, so the speed is going to be 16 meter per second. So must be very careful on that. Okay, so now move on for the acceleration. So for acceleration, it's going to be the derivative for velocity with respect to time. So it will be differentiate the v that we have here. Okay, so this is how we get 12t minus 20. So when t equals to 2, then our a is equal to 12 multiplied 2 minus 20, which will give me the answer of 4 meter per second square. All right, so 24, yeah, 4 meter per second square. All right, so I hope that you don't have any problem here. I think it's pretty straightforward. All right, so let us try to move on to the next question. All right, number two, a particle moved forward and backward along a straight line so that its displacement s meter from the initial position at time t second is given by the equation here. So find the distance that it travels in the first 5 seconds. Okay, so this question seems easy. Then it seems like, why not I straight away can substitute t equals to 5 in this equation that I get my answer. Okay, so this idea is correct if let's say we are finding the displacement. But the problem here is we want to find the distance and we doesn't know that whether this particle is because this question also tells us that the particle move forward and move backward. So the distance is going to be much more larger than the displacement because for the displacement we only look at the final position, right? But the distance is going to be like much more than that. So that's why in this question, what do we need to do is we need to get the point where the particle changed the direction. Then only I know that which is the time that it stopped. Then I know that where is the time it changes direction. Okay, so the first thing that we need to do is to get the time where the particle is at rest. So which means that's the place where the particle is having the maximum displacement. Then only by looking at that, then we only know the distance. So s is equal to 2t to the power of 3 minus 12t squared plus 18t. All right. So to find our maximum the maximum displacement, then we need to use the velocity, right? So when velocity is equal to 0, in another words, the ds dt is equal to 0. All right, so let us try to differentiate it. Then I'll be able to get 6t power 2 minus 24t plus 18 equals to 0. Then I can simplify by using 6. So t squared minus 4t plus 3 is 0. So from here, then I'll be able to solve at t minus 3. T minus 1 is equal to 0. All right. So by having this, then now I know that when t equals to 1 and t equals to 3, the particle actually changes its direction. Okay, so now let us try to see what happened then. So what we need to do is to find the displacement when t equals to 0, meaning at the initial point, then t equals to 1, the changing direction, t equals to 3, the other changing of direction, and the end, which is t equals to 5. Then after that, we'll have a diagram, then we'll be able to know how to calculate the distance. All right, so let's start with the first one. So when t equals to 0, so you can imagine when I substitute 0 here, then I think it's quite obvious that I'm going to get s equals to 0. So when t equals to 1, then we need to substitute s is 2, 1 cubed minus 12, 1 squared plus 18, 1. So this will be able to give me an answer for 8. Okay, so when t equals to 1, s is equal to 8. Then after that, when t equals to 3, so what is the s then? So s will be 2, 3, 3 minus 12, 3 square plus 18, 3. Okay, so by calculate this, then I'll be able to get 0. So you can imagine that what happened here is that it starts from the initial point, moving to the right hand side at t equals to 1. Then after that it stops, then it changes direction, come back. So it takes 2 seconds to go back to the initial point. So that's why it come back to the origin when t equals to 3. Then after that, let's try to check t equals to 5. Okay, So we have s will be equal to 2, 5 cube minus 12, 5 square plus 18 times 5. So from here, then I'll be able to get 40. Okay, so if we try to draw it in the diagram, right, how is that going to look like? So if let's say this is 0, so which means it moved to here for 8, okay, then this is t equals to 1. So then after that, it changes direction. So come back to here, sorry, this start with t equals to 0, right? Then come back here again for t equals to 3. Okay, then you can see that the displacement here is 0, so that's why it's another 8 here. Then after that, what happened is it changes direction again, right? Then this is where it reaches t equals to 5. And the displacement here is 40, so that's why another distance here is 40. All right. So by having this, actually, you can just look at the number also without the diagram. So from 0, 8 is 8. From 8 to 0 is 8. Then, because for distance, we don't care about whether it's positive or negative, right? Yeah, you just want the distance. So from 0 to 8 is 8. From 8 to 0 is 8. From 0 to 40 is 40. So that's why in this case, the distance will be just equal to 8 plus 8 and then plus 40, then we would be able to get the answer for 56 meter. Okay, so if let's say this question is asking you about the displacement, then you don't need to do anything just by substitute this, then 40 is your answer because the net change of the particle is basically 40. Okay, all right, so that's the idea. So now let's try to look at number 3. All right, number 3, a particle move on a straight line through the origin, so that its displacement s from O at time t second is given by this equation. So find the total distance covered in the first 12 seconds, then what is the acceleration of the particle when it is actually at rest. Okay, so these are two different questions here. So you can see this question is more or less similar like question 2, but I'm putting it because I want you to realize that for s, right, it's not necessary it always start from t equals to 0, then s equal to 0. Yeah, so for this case, which means you can try to miss out that if you didn't find out what is your s when t equals to 0. Okay, so let's try to find the first one first. So we know that the same thing, we need to find out what's the turning point of this particle first. So s is equal to 4 plus 12 t squared minus t cubed. Okay, so you can always pause the video, then you try it by your own, then after that you check your answer. So similarly, I want to find when the particle is at rest. So v is equal to t0, so which I try to find ds dt is equal to 0. Alright, so from here then I'll be able to get 0 plus 24t minus 2t squared is equal to 0. So bring it to another side, then I can get 2t squared minus 24t is equal to 0. Alright, so by having this, so, oh, I'm sorry, 3t squared, my mistake. Yeah, okay, bring 3 forward. Okay, so I have 3t, then after that t minus 8. So it start from t equals to 0 and also t equals to 8. So which means when the time first started, the particle is actually at rest also, then it eventually it speed up, then after that reaches the certain displacement. Okay, so similar thing we need to find out for 0, 8 and then the 12 here. So it's easier because this one it only changes direction like for one time only. So when t equals to 0, so we can have our s is equal to 4 plus 12 0 square minus 0 cube. So that's why for this question you can see that the s is actually starting from 4. So which means the origin point is actually not the starting point of this particle. So that's why you must be very careful in this kind of question. So when t equals to 8, then s will be equal to 4 plus 12, 8 square minus 8 cube. So from here, then I can get 260. Okay, so then after it reaches 260, then it changes direction, right? So I will assume that for this number, it should be a number that is lesser than 260. So when t equals to 12, so s equal to 4 plus 12, 12 square minus 12 cube. So I'll be able to get 4 here. Okay, so which means that this is your distance. So if let's say this is the origin, right, the particle eventually like start somewhere here. Okay, so if let's say this is 260, so that's why it's like going there, then after that coming back at here. Okay, so that's the idea. So in this question, the total distance is basically 2 times, right? Because for so go and come back, so you have 2 and then 260 minus 4. Okay, so this is how you get your answer, 1512 meter. All right, so we move on to the next part. So what is the acceleration of the particle when it is at rest? Okay, so it's different thing. So when it's at rest, it doesn't mean that the acceleration is zero. So when it at rest, it actually means that the v is zero. Okay, so which means this question is asking that when the particle is at rest, then what is your acceleration? So for this case, then which means that when v equals to 0, just now we already get our answer, right? When v equals to 0, the time is actually t equals to 0 or t equals to 8. Okay, but for this one, because we talk about when it start, then after that it at rest, so that's why we are going to take the t equals to 8 lah. Okay, so what we are going to do is to find the a first. So a is derivative of velocity over the time. So by differentiate my velocity equation just now, so which is this one. Okay, so I'm sorry, so I should refer to the SDT. Yeah, so I should refer to this one. All right, so make sure that you are taking the one that without you bringing to another side first, because this is your DSDT. So you can change this to the other side because of your solving is equals to 0, but the expression is this one. So make sure that you don't take the positive 3t square. So that's why when you try to do this, then you'll be able to get 24 minus 6t. Okay, so that's the A. So that's why I want to check what is the acceleration when it's at rest. So t equals to 8. So A is equal to 24 minus 6 multiplied 8. So we will be able to get negative 24 ms per second square. Okay, so this is a logical answer also because you see, when the time is at rest, right, meaning that the velocity is actually decreasing until 0. So that's why your acceleration should be a negative number. But it can be a positive also if let's say it happened at the negative side lah. Yeah, so that's the idea. Okay, so now let's try to look at the last example. Okay, number 4, a particle move in a straight line so that its displacement at time t second is going to be s. So you see this is only applicable for the time interval from 0 to 10. Okay, so it's given by this equation. So A, the question wants us to sketch the shape for velocity time graph. All right, so first thing that we need to do is obviously to find the velocity equation first. So we have S is equal to 1 over 3t cubed minus 6t squared plus 15t. Alright, so to do A, so which means we need to get the velocity equation first, then only we know how's the shape, right? So yeah, by looking at this, then you know that your V should be a quadratic equation lah, because this is power 3. Okay, so the velocity is equal to ds dt. So let's try to differentiate the displacement with respect to time. So moving in front, then I can get t squared minus 12t and then plus 15. Okay, so which means that I'm going to draw a graph of v equals to t squared minus 12t plus 15. So this is a quadratic graph. So that's why some important thing for us to find is maybe the x-intercept, y-intercept, and this is only valid from 0 to 10. So which means you will need to find t equals to 0 and t equals to 10 also. So let's try to do that first. So when t equals to 0, so as you substitute, then you should be able to get v equals to 15, or you can just read from the last answer, last number here, which is the y-intercept. All right, then when t equals to 10, so let's try to substitute. So our v is going to be equal to 10 squared minus 12, 10 plus 15. Okay, so from here I can get negative 5. So this is where my graph should end. Okay, so this is very important. Then after that, we might need to find out how many point, because this is quadratic, right? We need to find out how many intersect on the x-axis that we have. So which means when v equals to 0, then I have t squared minus 12t plus 15. So you can always use your calculator to help you to solve, and you will be able to get like a decimal number. So that's why you need to do the quadratic formula. So negative b plus minus b squared minus 4ac divided by 2a. Okay, so I'll be able to get 1.42 and also 10.58. So you'll realize that when you try to draw, right, you wouldn't be able to see two intersect points. The reason being is that your graph should actually ends at 10, negative 5. So this is already 10.58. So that's basically out of the range that we want already, which is from 0 to 10 seconds. Okay, so that's why you must always refer to the interval, the time interval that's given. Okay, so let us try to draw the graph. So let me try to draw here. So this is the line. All right, so we have our v here and our t here. So we can see that the y-intercept is at positive, right? So it should be starting at the 15 here. Okay, then what happened is it's going to be intersect the x-axis at here is 1.42, right? After that, it will eventually going up because it's going to be intersect again at 10.58. But then because of this graph is only valid until 10 seconds, so that's why it should be somewhere like here, then it stopped. So this is the point where I have 10 here, and this is basically negative 5. Okay, so that's the idea. So you need to show the, what is that called, your starting point and also your ending point. Oh, sorry, my fault here. I shouldn't draw it outside because the time cannot be lesser than 0. So that's why it's just going to be like this. Okay, so that's the idea. All right, so yeah, make sure that you cannot draw outside here because the time cannot be a negative one. Yeah, okay, so that's the idea for A. Okay, so B, hence find the maximum speed of the particle. Okay, so actually for this question, you have two ways to do this. So the first thing is because you have this graph, so that's why you can imagine that actually the maximum speed is either happen here. Okay, so maximum speed we try to talk about is no matter it's positive or negative velocity, right? So that's why the maximum can be happen either here or it can happen either here. So the first approach that we can try to do is by using the quadratic equation. So what is this? This is basically the minimum point. How can we find that? So we can do by using completing the square. So that's the first approach that we can try to do. So we try to check it out. So now we have like 2 points that we already know, right? So obviously the first one is t equals to, when t equals to 0, then the v is equal to 15. So this is one of the possible answer. So the other one will be at the minimum point here because this can be the maximum as well because we try to ignore the negative number, right? So this cannot be the maximum already by looking at this graph. So that's why what I can try to do is I try to complete this, do completing the square. So v is equal to t squared minus 12t plus 15. Okay, so by completing the square, then I can get t minus 6 square minus 6 square plus 15. So this gives me t minus 6 square minus 21. Okay, 36 plus 15, yeah. All right, so it actually tell me that I have a minimum point at the part where t equals to 6 and the velocity is negative 21. So this minimum point exists in your point, right? So that's why, meaning that when t equals to 6, your v is negative 21. So when I change this in speed, so this is definitely going to be bigger than 15. So my answer, it should be maximum velocity, or sorry, in this case is maximum speed, is going to be 21 meter per second. So this is one approach which by using the support of this graph. Okay, but if let's say you don't have the graph, then the easiest way to do that is just by doing maximum speed, meaning that your dv dt should be equals to 0. Okay, then what you can try to do is you just differentiate your answer. So we have just now v is equal to t square minus 12t plus 15, right? So we can continue to differentiate it. Oh, I'm sorry, this is not, this is all. Okay, yeah, so my dv dt is basically equal to 2t minus 12. All right, so if dv dt is equal to 0, so which means 2t minus 12 is equal to 0. So I'll be able to get t equal to 6 seconds. Then I substitute back into my equation for velocity. So 6 squared minus 12, 6 plus 15. So from here, then I'll be able to get 36 minus 72 plus 15. So which will give me the answer for negative 21 also. So after I have this, so that's why the maximum speed is actually equal to 21 meter per second. Okay, so I hope that you can get the idea of this. All right, so that's a part for the examples. So please remember to finish your homework before, yeah, because for this question, right, you can see for the exercise, that's only like 3 past year question because a lot of it actually involve integration. So there will be quite a lot of number of questions for Monday lesson. So please spend some time in this weekend to finish this homework. So try not to accumulate until Monday. All right, so that's it for today's lesson. So see you next Monday. All right, thank you.